Hello, my dear student friends. Today, again, I am back with a new video on biostatistics. This is my YouTube channel. Please subscribe, like, and share among your friends and students of other colleges. So, in this video, we are going to discuss about the sampling, and sampling methods. This topic is very important for theory because you get a short note on this short answer question, and in the practical exam also sometimes they ask you to define sample or sampling methods. Also they ask you to enumerate, or maybe they ask you to write down about one of the sampling method. So let's see about this topic of sample and sampling. So why there is a need to have a sample? So whenever we want to perform a study in a community, take the example of a village where you want to study the prevalence of hypertension by recording blood pressure. If the population of village is 5,000, will you go and examine all the 5,000 people of that village for blood pressure? No, because it will take a lot of time, it will take more manpower, it will take more time. So it will be difficult to record the blood pressure of all 5,000 villagers. So in this case, what we do? We take a sample of the 5,000 people depending on the sample size. So sample size calculation is a different topic. We will have a separate video on that. So depending on the sample size determined, we are supposed to select that number of samples from the whole village. So we will select the sample from that village for performing the study of prevalence of hypertension in the village. So we will take a sample by particular sampling method. So let us see what do we mean by the sample. The sample is a small part of a population selected for performing study. So like in 5,000 population, if you are taking 500, so 500 will become your sample. Then sampling is a process of selecting sample from population for performing study. So it is the process of drawing a sample from the population, that is called as sampling. And we have various types of sampling methods. So to study a large proportion of individuals or items or units, we take a sample. Easier and more economical to study the sample than studying the whole population. So that's why we need to draw a sample and perform our study on that sample and apply your results to the population from where you have drawn the sample. So great care is taken in obtaining a sample to ensure that the group of people or items selected as sample are representative of the whole population. Means they should have the same characteristics which the population is having. Then our study will be scientific and valid. So take care that whenever you select a sample from the population, the sample should be representative of the population. What is sampling frame? So the accuracy and completeness of the sampling frame influences the quality of the sample drawn from it. So the sampling frame is very important when you are going to select a sample from the population. So we need to define the target population for performing any study. So what is target population? Population of interest in which the researcher wants to generalize the results of the study. So a whole universe, you can say is the population, or you can say the population of India or population of Maharashtra. Then sampling frame is a part of accessible target population for study. Like in this example of hypertension in a village, village is the target population. So from where we take the sample can be taken from accessible target population and not from the entire target population unless researcher has access to entire target population. So sampling frame will be the number of people from a target population to whom researcher has the access and he can draw the sample from that. So when we actually draw the study subjects and take a sample, that will become the sample for our study. So listing of members from which sample is to be drawn is the sampling frame. Now coming to the sampling methods, this is very important. So whenever we draw a sample from the population, we follow a particular sampling method. And there are two major types of sampling methods. One is probability sampling and second is non-probability sampling. Probability sampling is also called as random sampling and non-probability sampling is called as non-random sampling. So among these two, probability sampling is very, very important because it is the most scientific method of drawing a sample from the population. So what happens in this type of sampling? That probability means the chance. All members of population will have equal chance of getting selected for the study. Therefore, it is called as random sampling. So the types of random sampling are simple random sampling, systematic random sampling, stratified random sampling, and cluster random sampling. So these are commonly used type of the sampling methods of random sampling. Whereas we have the non-random sampling or non-probability sampling, so it does not give equal chance of getting selected to all members. So there is no equal chance and anybody can be get selected and some people may not get selected. So the types are convenience sampling, purposive sampling, snowball sampling, and quota sampling. So convenience sampling and quota sampling is most commonly used in case of non-random sampling. Now coming to the simple random sample. So what we have to do in this type of sampling method, here we have to go for make a list of units in sampling frame. So suppose we have the population of 5,000 and from that we need to select 500 people. So what we will do, we have to make a list of sample in the frame, assign a number to each unit. Like here they have given the units or the individual samples and numbers will be assigned to them. So you can see the number are in the sequence. In case of simple random sampling, we are supposed to give the numbers in the sequence. And after that, we need to choose the sample from the sampling frame. So what we do, use a random table or generator to select random unit numbers. So these numbers can be obtained from the random table and from there you have to select particular number and that individual will be selected for the study. So like this, we go on selecting the sample from the sampling frame in case of simple random sampling. So random numbers are a haphazard collection of certain numbers. So even if the BioStatistics books, they have these random numbers at the end of the book where we can have this number. So what are they? They are arranged in a cunning manner to eliminate personal selection of unconscious bias in taking out the sample. So can provide greatest number of possible samples. So it is the simplest and easiest method of sampling from the random sample. Now second type of random sampling is systematic random sample. So what we have to do here, make a list of units in a sample frame, assign a number to each unit, pick every 5th or 10th unit at regular interval. So here we have to follow a particular class interval and every 5th or 10th or 20th or 100 or 500 number can be selected from the population. So here also we have to give the numbers to the sampling frame in sequence. And then we have to select the sample from the sampling frame. So each unit in the sampling frame would have the same chance of being selected but the number of possible samples is greatly reduced. So here the number of samples will be reduced, whereas in simple random sampling, the number of samples will be large in number or huge in number. Third method is stratified random sampling. So here we need first to define the target, then recognize stratification variable. So here we have to identify how you are going to stratify the population. Recognize each strata and assign numbers to each unit of strata. So here you can see there are 4 strata being given here depending on the different characteristics of the strata. So each strata will have a particular characteristics. Pick random units from each strata. So what we have to do, so you can see here in each stratum they are giving the number in the sequence, not in the number for the whole population in sequence. So each stratum will have its own numbering method, and from each strata you have to select a particular number of samples so that the sample is drawn from each and every strata, and the sample selected is the representative of that particular stratum. So like this, we have to go for selection of the sample from the strata. Sample is deliberately drawn in a systematic way so that each portion of the sample represents a corresponding strata of the universe. So this is useful in analyzing the data by a certain characteristics of the population like religion, occupation, all these factors can be considered. Now next is the convenience sampling. So obtain sample of convenient elements, eliminates convenient elements. Respondents or units are selected because they happen to be in place at right time. Like take the example of doing the prevalence of hypertension in the village. You visit a particular ward or area of the village, and it is convenient for you to select the people from that ward. So you go on selecting them from that particular ward. So that becomes a convenient type of sampling, and you feel that this sample is the representative of the village. So here we don't do any random sampling. We just go on selecting according to our convenience. So here, what is the use? We can have interviews with the population, and quick collection of data is possible. It is very inexpensive and fewer rules need to follow, but it is an unscientific method of selecting. The results obtained in this type of studies are not much valid. Then second, non-random sampling is purposive and deliberate sampling. So what we do here, the investigator himself chooses or selects the samples from the universe, which in his opinion is the best representative of the population. Take the example of a classroom, and teacher wants to know the performance of the students. So what he will do, he has taken the class and now he will select those students who are very good in studies. This is called as purposive sampling, and the results obtained will be biased in this type of sample. So this is all about the sampling and sampling methods. Little bit about the sampling error and standard error of mean we'll see here. So suppose we are performing a study on prevalence of hypertension in a village, and we have taken one sample of 100 from 5,000, and we perform the study and we get x1 bar as the mean of blood pressure from the sample 1. Then you take another sample, sample 2, take the 100 people, record the blood pressure, find out the mean blood pressure, that is x2 bar. Like this, third sample, fourth sample, fifth sample. So like this, in each sample, the mean of the observation will be different. So this type of variation from one sample to another sample is called a sampling error. So because of the selection of the sample in different methods, we get different results. This is called a sampling error. It occurs because data were gathered from a sample rather than from the entire population of the concern. That's why there are some variations. So the factors that influence the sampling error are the size of the sample and the natural variability of the individuals. As the size of the sample increases, sampling error will decrease. That's why we need to take a large enough sample to avoid the problem of sampling error. As the individual readings vary widely from one another, we get more variability from one sample to another sample. So that is another reason of the variation between two samples. Non-sampling errors means it is not because of the sampling, because of some other reason. So errors may be due to inadequate calibrated instruments. Now you are using sphygmomanometer for recording blood pressure, but it is a faulty instrument. It is not calibrated. It is not standard one. Then you will get the wrong readings due to observer variation. The person who is recording the blood pressure is not able to record the blood pressure correctly. So that will also give variation. Due to incomplete coverage achieved in examining the subject selected and conceptual errors. So these are often more important than the sampling errors. So non-sampling errors also have the effect over the outcome of the results. Now let us understand the concept of the standard error of mean. So if we plan to take a study on prevalence of blood pressure in a village, we take one sample of 100, record the blood pressure, and then find out the mean. This is mean 1 x1 bar. Like for second sample, we calculate the mean blood pressure of x2 bar. So like this, we take different samples and draw different means of blood pressure from the same population. If we make a frequency distribution of all the sample means drawn from the same population, we will find that the distribution of the mean is nearly a normal distribution. Like in case of normal curve, we were putting the values on x and y axis and we were getting the normal curve. So in that, the observations were lying above the mean. Now in this case where we have various sampling means, these means will be distributed above the population mean, which is denoted by mu. So the mean of the sample means practically the same as the population mean. When we take the mean of different samples, that is called as population mean. So mean of mean is the population mean, or you can say when we record the whole population blood pressure and we find out the mean, that is called as population mean. So this is a very important observation, that the sample means are distributed normally about the population mean. So in case of when we draw various samples from the same population and find out the means, and we plot these means on the x-axis and y-axis, we get the normal distribution. And here the sample means will be distributed around the population mean. So the standard deviation of the means is a measure of the sample error and is given by the formula standard deviation by under root n, which is called the standard error or the standard error of the mean. So we get the standard error of the mean by dividing the standard deviation with the population under root. Since the distribution of the means follows the pattern of normal distribution, now what will happen? The means which are distributed around population mean will have the rule of 95% of the sample means. They will lie within limits of 2 standard error. So the observations were lying within the 2 standard deviations from the mean. So here the means will lie in the range of 2 standard error from the population mean. So on either side of the 2 or population mean. So 95% of the observations or sample means will be within normal limit. Therefore, standard error is a measure which enables us to judge whether the mean of a given sample is within the set confidence limits or not. So with the help of standard error, we find out about the mean of the sample, whether it is within the limit or not. So this is all about the sampling error and standard deviation of mean. So I hope that you must have liked this video on sampling and sampling methods, and a little bit about the sampling error and standard deviation of the mean. So I request you all, please subscribe my channel, like this video and share this video in your groups. Thank you very much.